kind of starting up here at the top. Okay, number 2, a couple of things I notice. I see pluses and minuses, so I'm going to get my parentheses in. I don't want to be that person, you know, the one that wants to cancel these x's when I can't. Okay, don't want to do that. So I look to see if there's anything I can factor. And I'm like, well, there's really nothing up in the numerator I can factor. I got to leave that alone. But then I look at the denominator, and I'm like, ooh, I see stuff. What do 7x squared and 21x have in common? 7x. So if I take 7x out, it doesn't disappear. Just means it's in a different spot. Okay, what do I have to multiply 7x by to get to 7x squared? X. And to get to negative 21x? Negative 3. Then the question pops up. Not the question, the am I done question, but are my 2 sets of parentheses the same? No. But hopefully we remember this. How do we fix that? We've got to take a negative out somewhere. Now, it doesn't matter where I take the negative out. Okay? If I want to take the negative out here and just put it with my negative 7, and we'll call it negative 7x, that would change the signs on both of these, because negative 7 times negative 1 is still be positive 7x squared. And negative 7 times 3 would be negative 21. So, I mean, that still works. But now, since these both have negative x and positive 3, they're the same thing. They look a little different, but they're not. So I cancel those out. And then you're like, okay, what have I got left here? I got a negative 7x. Well, Harty, there's nothing left up here. Oh, but there is. Yeah, I've got to put a 1 up there. I got to have something in the numerator. So if all I got left is stuff in the denominator, I got to make sure I get a 1 up there. I get myself into some issues here. So that's one of the things we can run into. Again, you may just be reducing the fraction that's there already. But then we boosted it a little bit. So let's say we go down to 5. Oh, there's a lot more to do this time. All right, piece by piece, here we go. Do those 2 terms have anything in common? 2k. So what's that leave me with to put in my parentheses? K plus 9. And again, if you're not sure, if you're like, I think that's right, you always can go back and distribute 2k times k, yeah, 2k times 9, okay. Kind of work that through. But we're just going to work piece by piece through these, making sure we factor everything we can. What about the denominator? Okay, 4 is the largest value that goes in. Now let's say you didn't get that, you got 2. It'll still work for the time being, but then you're going to find out later you can take some more. And then I liked hearing k squared, because remember, when we're dealing with single variable terms, we always take, when we're factoring, we take the smaller one. Okay, when we're building an LCD, we'll take the bigger one, but we'll get to those in a little bit. So let's see here. 4 times 3 gets me to 12. And 2 plus 1 gets me to 3. And then 4 times 8 is 32. And I already have all my k's, so I don't need any more. So I'm going to leave that one alone. I notice we're multiplying this time, so no flipping. Common? It's a single-digit number. I know that really narrows it down, right?
3.
3 would, but it's bigger.
6.
6. Whoops. No, 6 times 8 is not 18, Harty. And again, let's say you took 3. Now I'm going to pop that up here for a second. Let's say instead of doing it this way, you'd have done 3, and then you worked it through, and you're like, wait a minute. 6 and 16, I can still take a 2 out of there. Okay, So I'd take the 2 out, and I would just multiply that by my 3, and I'd divide each of those by 2. So I'd end up in the same place at the end. It just would take me one extra step, because I'd notice not much would be canceling at that point. And I'd be like, well, this kind of sucks. Oh, wait, I got to get that done. Okay. And then k and 9 don't have anything in common. Once I've cleaned up and factored everything that I can, now I can start whacking away at things. So k plus 9s are identical, I can cancel them. 3k minus 8s are identical, I can cancel them. And usually at this point is when I'll go ahead and I'll multiply across, unless I see something that's just identical completely. So I'm like 2k times 6 is 12k. And then I got 4k squared in my denominator, but I notice, okay, there's going to be more I can do. No more bonds. So everything's fair game to cancel or reduce at this point. So 12 divided by 4 is 3, but since 12's bigger, the 3 will go on top of my fraction. And then, right, 2 minus 1, because again, division with variable terms, we subtract the exponents. 2 minus 1 is 1. Bigger exponents down in the denominator, that's where my k has got to go. So all those rules are still popping up. It's just, you know, we've got to take things piece by piece. So let's see, we've reduced a fraction. We have done multiplication. All right, let's chat division here. We'll do 7. I'm not going to do like half of this with you, but I'm going to make sure, especially when we get to the adding and subtracting problems, we hit a few up here. All right, do not be the person that tries to cancel the 7n squareds. That's what I'm going to be writing like, on your quiz. Like, what are you doing? Not paying any attention, that's what you're doing. Okay. Common? 7n. Now I'm getting some of you with a stronger voice on this. This is good. So we get that factored. Moving our way along here. What about the denominator? 7n. Well, how convenient. Okay, moment of truth on this problem. Do I pay attention to the fact that it's division and remember what to do? All right, all right. Those suckers got to get flipped, and this becomes a multiply problem. So I'll do the easy part first. Yes. Because dividing by a fraction is the same as multiplying by its inverse, or its flip. So when I go to see what I can do to factor that, that's what's going to go up in the numerator now. So what do those two guys have in common? 4. Anything? 4n squared. Because 4 is divisible into both, and again, the smaller of my two exponents is going to be my common factor. Got n minus 2. And then it becomes a cancel fest. So again, any sets of parentheses that are identical, top to bottom or cross, I can cancel. So n minus 2, see ya. N plus 8, adios. 7n's, see ya. It's just 4n squared. And a lot of times you'll see a lot of things that cancel. Now sometimes you may only cancel like a single number. That happens sometimes. But otherwise, not a bad deal. All right, let's see what else we got working here. Looks like number 11 is my next target. Now, as we hit up this next group, okay, this is where, if you're still a little bit like, well, I'm not sure about this stuff, again, refer back to the help sheet that got worked through yesterday so you can remember how to build your fractions, what parts there are to find in my common denominator. Because that's what we're going to talk through right now. So, okay, didn't have parentheses there. And again, when I'm trying to find a common denominator, it doesn't matter what's going on up in the top. So I look. Are there any coefficients hanging out outside the parentheses? No. Are there any single variables hanging out outside the parentheses? No. Oh, okay, well, it's going to be easy then this time. Because it's just the different quantities, the different sets of parentheses that I see. That's all it's going to be this time. Didn't really have to think much at all. So I get that set. And then my puzzle builder, my fraction builder, whatever you want to call it, mode, jumps into play here. Whatever I've got to multiply that old denominator by to get to the new one is what I've got to put up in the numerator. So sometimes people look at it as multiply. Some people look at it as a puzzle and they say, hey, I got this puzzle piece already, but I don't have that one. So I got to put it in my collection up here in the numerator. And then I got to do the same thing on the second one. I got the x plus 1 piece. I need the x minus 4 piece. Get that up there. And then it basically becomes your choice on how quickly you think you can get this cleaned up. Because notice, I do have to do distributing here. And I personally like, so I don't have to rewrite this like 5 times. Yeah, just jotting down up above what that's going to equal once I actually distribute it through. Because then I can hopefully have this next part be my last step. Now we'll see. I may have to do something else. I don't know. 6x plus 6x is 12x. 6 plus negative 24 is negative 18. I always first look to see if something cancels at the end. Well, I don't see anything canceling. But, just to be sure, do those two terms have anything in common? 6, okay. 6 will go into both. Now, so does 2. And yeah, 3 would as well. And again, I'll answer this again because I know the question's floating in somebody's brain. Well, if I'm not going to be able to cancel anything, and I can't, why do I even bother? Because about the time you don't bother, that's going to be when something cancels. So I always say it's better to be safe than sorry, but maybe you'll get lucky. Maybe you'll get to hear it and circle it, and there won't be anything else that cancels, and then you'll still get all the points. But just saying. Yeah.
So all you did was like add the 6 in front of parentheses and each. That's how you got the
How I got these guys?
No.
Or this?
Yeah.
The red stuff? Basically what I did on those, let me grab one of these here, is let's kind of look at it sideways. What I'm doing is I'm saying, okay, here's my original denominator. My job at the end is to get it looking like this. So the question then becomes, let me get my 6's there. The question becomes, what do I have to times this initial fraction by to get out to here? Well, I'm like, well, wait a minute. I've already got this piece. I've already got this x minus 4. So x minus 4 times x plus 1 would get me this. And whatever I do to the denominator, I've got to do the same thing to the numerator. So that's where this 6x plus 1 is coming from, and how the x minus 4 is going to come about in the second one too. So if it's more sensible for you to look at it this way with a little bit of side work, that's not a bad idea, because you notice that didn't take me really long at all to be able to do, and it's a solid way of doing it. Everybody's got to find their own way. Let's go, good question. I'm glad you asked. Okay. 13, same idea. We're still adding. But again, I run down my checklist. I'm going to move this up a little bit higher, so I'm going to try to get my checklist on the screen here. We'll see how this works. Not too shabby. Okay. Number 1, look for coefficients. Got one. So we're going to get that in here. So 2 is part of my LCD. Look for single variables that are not bound by plus or minus. Well, I have a variable, but it is definitely bound by plus or minus. So I don't have any of those. Unique quantities, sets of parentheses, v plus 1.
So basically everything in the denominator automatically like goes in the denominator of both of them?
Yes, whatever you see in either one of the denominators is going to show up in both when we find a common one. Yep. So, when I look at this now, I go, okay. Again, here's what my whole focus is right now. Here is my old denominator. Here is my new one. Whatever I'm multiplying this by to get this is what I need to put up here. So I'm like, okay, well, I already got the 2 part, so I need that's v plus 1 that's still there. And when I do it the second time, okay, to multiply it from v plus 1 to get 2 times v plus 1, I already got the v plus 1, I need the 2.
Looks like you're just switching, like flipping sides from the top.
On some problems, that will be the case. It almost looks like I'm doing a cross multiply. And that will occur at times, but it's not going to occur every time. So I'm not going to make that assumption. So when I do these, and again, we multiply it out, we got 5v squared plus 5v. And over here, I got 6v. So basically now I'm just going to put all this stuff together and see, you know, can I reduce it? Can I not reduce it? How's this going to work? So I only got one v squared term, so 5v squared. 5v plus 6v is 11v. Before I circle it, I always look at the numerator and I say, okay, is there anything else I could do? Now, in this case, I notice I don't have a v. Now, hang on. I'm gonna repeat what I set up above. I understand that that's not going to get me to a place where anything cancels. Technically, either one of these answers is right. Okay? But again, it's going to be that time that you go, nothing's going to cancel anywhere anyway, that you don't do it, and then something's going to cancel, and you're going to be like, oh, crap. So I would say just do it. But again, if you want to stop after you get here, because that's taking all the brain power that you have, that you got to do what you got to do. Well, I agree, but I'm just saying. I want you to get like a killer high score here. All right, 2 left I'm playing with you on. Here's one of them, 19. Ooh, that looks like fun. All right, denominators. Can I factor that second denominator? 19. Yeah, okay. What do they all have in common? 2. So let's take 2 out, and then let's look again. All right, 2 out of there. Now again, it's there still, we've just moved it to the front. Now let's look inside the parentheses. Looks like a possibility of a diamond problem. We got to at least try it. So let's see here. 2 numbers that multiply to -8, so it means there'd be 1 plus and 1 minus. Oh, it does factor. 4 and 2. Okay. We're going to scribble out all these other steps that we did because we don't want to get confused when we're building our fractions on what we're using here. So I get that factoring done, which is always what I need to do first because it's going to simplify things whether you believe it or not. All right, let's get to work here. Coefficients. 2 and 2. I wonder what my coefficient's going to be. 2. Okay. I do have a single variable term that's not locked up with a plus or minus, so that's part of it. And then I have 2 unique sets of parentheses that also each need to be part. You're like, ooh, that's a big old denominator. And of course I have to put up here what I already have. Because I can't lose that part or I do mess up my whole problem. Like, all right. Now this first one is going to get a little messy. Because you're like, I'm trying to get from here to here. I mean, I see I've got the 2k. Okay, that's fine. That's dandy. But I didn't check off the k plus 2 or the k minus 4. Yuck. So, we're going to have a little house cleaning to do here in a minute, but that's not going to be terrible. But on a nice point, there's going to be very little we have to do to the second one. It would just be k, because I get rid of all those, and I check the 2, but I didn't check the k. So I'm going to tuck that in front here. So you're like, okay, how the heck am I supposed to deal with all of this? Well, I'll tell you what I would do. I'm glad you asked. I would take that 4k. Now, distribute, but only to the first set of parentheses. Otherwise, you're going to get a big mess. You know what? Now, in retrospect, I wish I could rewind on my video. In retrospect, no, I'm not going to do that. Okay, so here's what we're going to do instead. I'm going to multiply this out. I'm going to FOIL this out. We're going to have to do it sooner or later, so we'll just do it sooner. So again, we're just dealing with what I got in red here. To match the fire that some of your eyes are giving me when I said we had to do a box. Okay. So I'm like, all right, so k squared minus 2k minus 8. All right, this is going to be one of those times that I am not going to skip a step because there's too much going on that I am going to miss if I don't do this. So, okay. I've got this that I just took care of all that stuff in red, but I still got to distribute that 4k through there. Okay, so that's what I'm going to start doing in this big old fraction that I'm going to have down here. So as we distribute that 4k through, I get 4k to the third. 4 times negative 2 would be negative 8k squared. I'm distributing through. K times k squared, there's 4k to the third. 4k times negative 2k, negative 8k squared. And then 4 times negative 8 is negative 32k. Okay, so now my first fraction's cleaned up. And then I'm just going to distribute my k through. I know, now you're seeing why I went ahead and wrote this out and just didn't try to do little tiny side scratch work. That's a lot of stuff to keep track of. And we're almost there. That's true. That's why it's good that we're almost there. So, I get here. Okay, I've only got one term that has a k to the third. And then I've got negative 8 plus 6. It'd be negative 2k squared. And negative 32 plus 5 is negative 27k.
Are we done? No.
That's a good question. You stole my line. The only thing we can take out is k, but we can. So we will. And we finally, how many problems in are we now? I lost track. I'll give you good news. What's in the parentheses isn't going to factor, so don't worry. No worries. Almost lost my place there. Okay. Finally, we have done some factoring at the end of the problem, and it actually pays off for once. Because look outside your parentheses. You have k, and you have 2k. Those are single variables. They're not bonded. I can actually cancel them. Well, if you have to do this, where you just cancel them and then circle it, that's fine. But that's why we actually go through and then try to factor it out, because you may be able to reduce further. And we got to make sure that we do that. But again, that's like, this problem is a worst case scenario. There was a lot that we had to do besides just, clean up a denominator and put them together. Okay, one more. One more. Last one, literally. Haha, 23. All right, let's see. Nothing to factor there, so nothing to see there. Why am I rewriting this already? I'm a goofball. Okay. Factorable, I'll answer the question for you. Yes. Take out a 2. Guess what?
Guess what?
You're never going to guess.
We done?
No, we done.
You said guess.
More of a legitimate guess on what you think I'm going to say next.
That's it.
You all don't know me very well
No,
then at
like,
this
that's
point.
all we need in the denominator. Oh, dang it.
Yeah, I was going to say, if you all think that that's all I'm going to say on something like that, you just don't know me very well.
That's right, we probably said that like 3 different times. Right.
So, it's factorable. That's right. Okay.
I guess. I said we done.
Exactly. I just guessed what I was hoping.
So I factored that out. Do my diamond. It worked, so I could actually do it. So I look, and I'm like, all right. Coefficient, but they both have 2, so I don't really have to think very much. It's not like I got to count off in multiples. I don't have any variables that are single, just ones that are bonded or attached already. Poor souls. So, I've got myself a common denominator. Here comes some legitimate, maybe, possibly, happy news. I look at my initial denominator.
So what do you have to do? Just write.
Well, and I compare it to the new one. Check, 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 check. Everything checks. That one's ready already.
So no R, no nothing.
Now, the second one is a little bit different of an issue. The second one, the only thing I get to check off is the 2. So yes, unfortunately, we have a situation like we did in the last one, where I have to do some cleanup work here. But luckily with 23, we got plenty of room this time.
We're not lucky. We're saying lucky. This is the longest problem ever about to happen.
Oh, no, it's not the longest problem ever. Oh, there's longer problems.
Oh, Jesus.
No, it's not this is not the longest problem you will deal with.
That, I think the last one was the
The
longest.
second longest.
The second longest. Okay, well, we've got that on tape now. We'll see as we move on if that's true or not. So, all right, let's see what we got working here. So once I get that boxed or foiled out, remember, I still got this 3r in front that I got to deal with. So when I go to make my big old fraction, as I distribute, and I'll explain why the parentheses are going in here momentarily. So 3r times r is 3r to the third. 3 times negative 9 is negative 27r squared. 3r times 20 is 60r. Now, why the parentheses? Because I'm subtracting the entire second fraction, that entire quantity. I'm not just subtracting 3r to the third. And if I don't put the parentheses, that's exactly what's going to happen. I'm going to do minus 3r to the third, and then I'm going to keep these signs the same, which isn't the correct thing to do. So when I'm getting my final answer ready to go here, I look and I'm like, okay, so if I start to distribute this negative, I've got negative 3r to the third, because I like to put my biggest exponent first. Do I have to? No.
Why are you doing that?
Because I'm not down to r to the first yet. This is my biggest degree. And then I'm like, negative times negative is positive 27r. And then this becomes negative 60r, but I have another one over here. So negative 60 plus 1 is negative 59r.
Wouldn't that be 27r squared?
Good job, y'all.
Nicely done. Because yeah, otherwise I'd be combining more like terms. So good call.
Is that
Yep, 59, because I got negative 60 plus 1. And then I got the minus 5 on the end. But here's your happy thing. No, luckily, oh, I just said it again. They don't have anything in common. There's nothing to cancel, because these are all bonded together. So that big, crazy, ridiculous answer is the actual final answer. Okay. We have now pounded away at this stuff for a week. We will pound away again one more day before we go to quiz mode. So,